Hi, everybody. It's Miss Miseraco again, and today is November 16th. Our topic is wind, the horizontal movement of air. And our learning target for today is you should be able to describe how wind forms, you should explain how local and global winds are different, and you should be able to identify and describe land and sea breezes. I will start the kids in class with a brain pop. I will link this video in the comments. So be sure to check out the wind brain pop. Remember, you need to record 3 terms, 2 facts, and a 1 sentence summary at the end of your digital notebook. Then the students will be taking some notes. So if you are at home learning or if you need to fill in some of your missing pieces, here's that information. Wind, again, is the movement of air. It is caused by differences in temperature and pressure. We remember that warm air rises, making the molecules move faster and spread out. This makes the air less dense. Less dense air is light and will rise. And we see that in the little picture over here. It looks like that's molecules escaping. Differences in temperature: cold air sinks. Cooling makes the molecules move slower and group together, and that makes the air more dense. More dense air will sink. Rising air creates low pressure. The air is lifted up, means there's less air pushing down on Earth. Sinking air creates high pressure. It's pushing down and exerting a high amount of pressure onto the surface. When we study weather, we'll learn that low pressure, when it lifts, that air mass is going to cool, condense, and make clouds. And oftentimes we see precipitation with low pressure, and high pressure kind of pushes the moisture out of the air, and high is usually associated with dry. So high is dry weather. Low, I remember a rhyme, low means snow and other forms of precipitation. Again, because that low pressure, the air rises, cools, condenses to make clouds. Differences in temperature cause air to rise and sink all over the earth. This causes high and low pressure. The atmosphere, as nature, doesn't like things that are unbalanced, so it tries to equal things out, where air always moves from high pressure to low pressure, thereby creating wind. Heating the air, again, decreases pressure. Cool air rushes in to replace that warm air. As the air goes from high to low pressure, that's where winds form. Wind, again, is horizontal movement of air. And we're going to look at 2 types today: local wind and global wind. Local winds are winds that blow over a limited area. They blow between small, low, and high pressure systems, and they're influenced by geography. If something is close to an ocean, a sea, or a mountain, it'll affect local winds. And I put a little note on there. What do we remember about how land and water heat up and cool down when we did that lab last week? Which one heats up and loses their heat more quickly? Was it land or water? Students will also watch a land and sea breeze video. I will link this in the comments as well, so you'll want to watch this and jot down some notes from the video.
Very much.
After watching the video, here's some additional information. Ocean water is slower to warm up and cool down than land. So the sea surface is cooler than land in the daytime. The water stays warmer than land during night, and these differences cause land and sea breezes. Sea breezes blow from the sea to land, and they happen during the day because that land heats up. It's now less dense. It rises, and that cool air rushes in. The opposite happens at night. The land breeze blows from the land to the sea. That's because the water is warmer over the water. It rises, and then the cool breeze from the land moves in. Sea breeze, where it's blowing from the sea, versus a land breeze, where it's blowing from the land. During the day, sea breeze; at night, land breeze. So here you're going to want to pause the video, look at this picture, and then explain in words how we're seeing these different breezes form. And then you want to label high and low pressure and draw on this current. We call this a convection current, where we see warm air rising and then cool air swooping in. Next, students will read about global wind. And then here's the answers to those: jet streams, Philly to San Francisco, convection currents, trade winds. Please reach out with any questions or concerns. Thanks for watching.